So with the Retro Computer Fest Pacific Northwest for 2020 canceled, they're putting on instead this event that is the Retro Fest. And so we've been asked to do little 5-minute videos on the machines we were going to bring into the Vintage Computer Fest, and this is my machine. And you can hear Daisy here wandering around behind me. That's the toenail tapping in the background, my dog. Anyhow, this is my Altair 8800 computer. It's what I'm calling a semi-replica, in that it uses a lot of replica parts. The case, it is a reproduction case that's available on the web. The front panel is reproduction. The electronics, some electronics inside of reproduction, so it's not an original machine. But the idea was to take this empty blue case that originally had an emulator in it and turn it into an actual S100 machine. You can see the photo here. I'm using two 8-inch floppy drives. It's running CPM22. They're really helping here, Daisy. Thank you. So here's the machine with power on, some LEDs lit. I think this is actually booted into CPM and the machine is running. So let's take a look at the machine and how it's turned out. This is looking down into the card cage, so you can of course see the card cage here. You can see the power supply behind it. We've got the CPU card up in the front here with an interface card that goes to the front panel. We've got four 16K RAM cards here. We've got a serial and parallel I/O card here. The TTY0 serial cable is, of course, this cable coming back here to the back of the case, and TTY1 here. There's a ROM card here holding 872A EPROMs that have Altmon and the common disk bootloader, etc. in it. And then there's the FTC Plus floppy disk controller. So this card here in the front is vintage. This is a new card. These guys are vintage. This is a vintage card. This is a card I designed that could have been manufactured back in the day. And this is a modern card again that emulates the floppy disk controller. So kind of another look down into the card cage of those cards. It's a 12-slot motherboard here in the back. They are each board holds 4 connectors. This is a reproduction of what was in the original Altair 8800. There's jumper wires that you can't actually see here that jumper the 3 blocks together. This is a look at the CPU card of the machine. So it's a WAMCO or WMC 8080 CPU card. Looking at some of the parts on here, I think this dates, there's 1980s here, although I think I replaced those. This card would have been late 70s, early 80s. You can see, I thought someplace on the card there was a copyright 1977, but I could be wrong. So this is the processor card we're running in the machine. It's obviously vintage. This is a look at the 8080 processor we're running in the machine. It's 32nd week of 87 is my guess at this date code. Nice white ceramic gold top. It runs well. This part is very vintage, but works very well. This is one of the 4 16K RAM cards I have in the machine. It's a Memory Merchant MM16K14. It's got 4 4K blocks up here, a number of jumpers to select where these blocks are in the system memory configuration. And this is the actual card that's strapped from address 0000 to 3 FFF hex. We've got that solid state memory IO4 card here that's providing TTY0 here, TTY1 here, and then it's got 4 parallel ports. You can see here that this UART's 28th week of 1979. This week the UART happens to be from the 7th week of 76. So again, as much of this card is vintage as possible. The card actually was manufactured in, I believe, 77 or 78. So it's a very vintage card. This is a modern card I designed for the Altair bus, the S100 bus in the machine, that holds 8 1702 EPROMs, giving me a total of 2K of space here on the machine for ROM. There's the Altmon monitor, the hex bootloader, the Termon, AMBL, and the CDBL, the common disk bootloader. This is the one I actually used to boot CPM on the machine. These can deal with paper tape and other ways of getting code into the machine as well. And the Altmon is an interactive monitor on the TTY0 device that lets you, set bytes in memory, dump memory, etc. I designed the card to hold these because I really like the idea of having, 1702 EEPROMs from the era actually in the machine. This is the 1702 EEPROM programmer I designed for the machine, based on an article on, I believe, Popular Electronics on programming 1702s. Every part on this card was available in the late 70s. So this card could have well been designed and manufactured back then. It just happens to be, I laid out a PCB for it and manufactured it myself just so I could program 1702As in the machine. This is a card that's not currently in the machine. It is an original MITS SIOB serial TTL card. This card, as originally designed, produces RS-232 that is at TTL levels. I've added this little blue board onto the card that converts those to EIA levels. And there's some jumper wires in here that have to do with dealing how the character weighting in the buffer and the transmit buffer is empty, how those signals get routed back to the machine. These jumpers made the card basically compatible with the version of CPM I had, or have. This card's completely removable. It just plugs into a socket and there'd be a line driver plugged in there, and of course these wires could be removed and that chip replaced with an original chip, or a chip from the era, and the card would be fine. So the mods I made were not destructive to the card. This is a look at the two 8-inch floppy drives I'm using. They're Shugart 801Rs, single-sided, 300K per disk. This drive was a lucky find in that I believe it's new old stock or very lightly used. The drive honestly appears new old stock, although it was sold as used. This is an older drive that I've picked up someplace that I've done work to get working. You can see the two AC motors sitting back here that drive the spindle. So the drives really do extend all the way back here, and these floppies really are 8 inches across. This is essentially a 19-inch wide configuration here with the two drives. And finally, I've got a Televideo 912C terminal that I use with the system, as well as using like TerraTerm on my PC. So with that, let's jump in and kind of do a quick demo of the machine being booted. So let's go ahead and get the Altar booted up. I need to apply power first. I'll go ahead and get the floppy drives closed. Sorry for the reach around the camera. I need to reset the machine. I'm going to examine address FF00. That's where the common disk bootloader resides on that 1702A EEPROM card we looked at. And we should be able to boot the machine. And we're in. And we can take kind of a peek around. Contents of the A floppy, the B floppy. We can run a survey on the machine, get a peek at the hardware. So a survey has told us that we have 2K of ROM up at the top of memory, and that's where that 1702A EEPROM card lives with the Altmon and the various bootloaders on it. We've got 60K of RAM. I've got a 2K empty space at the moment here in the machine. We've got the BIOS up here. We've got CPM, and we've got the TPA, which is the transient program area where CPM actually loads code for execution. We can see the machine's telling us 62K of RAM, 2K of ROM. We can run something up to 56,070 bytes in the TPA. The active I/O ports, these are in hex. 10 and 11 is TTY0's UART. 12 and 13 are TTY1's UART. And the 0 to 8 through B are the floppy disk controller in the machine. So we'll go ahead and, if I can type, do a little something in BASIC just to exercise the machine a bit. Print. Code 5. And there we go, a little simple BASIC program running. We'll go ahead and shut the system down. Really nothing to do at this point, but open the floppy drives and not have a disk fly out onto the floor. Sorry about the reach around the camera. Shut the power off, and we're done. So there it is. Hopefully you enjoyed this little video and a look at some of the cards, and we'll talk soon.